video, we're going to explore the use of the Math Toolbox for a loading calculation. Now I have a whiteboard set up here that allowed me to calculate the flow data for a particular creek, and I'll just talk through what we've done so far. The first thing I did was import some rating measurements, and then we used the rating curve development toolbox to actually develop a rating curve for my site on Charlie Creek. And then we passed that rating curve to the rating curve player. Now in order for the rating curve player to work, we needed some water level data. So I imported some water level data here from a file, and then I did some pre-processing on it. I had a few 15-minute data gaps, so I used the pre-processing toolbox to interpolate across those small gaps, and then I passed that to the rating curve player as well. And you can see on the output of the rating curve player, we actually have quite a good time series of flow data. You can see right here we've got a good time series, generally fairly low flow in this particular area, but sometimes we get some pretty high flows up to nearly 4,000 CFS. So what we want to do now is actually bring in our sediment loading data, or our sediment sample data, and to do that I'm going to use an import from file toolbox. So I'm going to drag it out onto the whiteboard, double click on it in order to run it. Now one of the things we want to be mindful of when we're bringing in this type of actual non-data logger data is we want to unclick this box, the fixed timestamp gaps box. Now what AQUARIUS will do if you leave that checked, it'll actually try and find a regular timestamp interval for you, and it'll insert blank time tags where you have jumps in your time tags. So we don't want to have that happen when we're bringing in data that's typically taken by grab samples. So I'm going to load this data in, and we've got Charlie Creek SEDS data here, and if I just choose to load that in, we're going to bring it in as a time series because I want to do some numerical operations on this data. So I want to treat it as a time series, but again we're not going to use the fixed timestamps option. So what we're going to do, we're just going to go through the import from file, specify where the data starts here. If I go across to the next step, we're going to say what the timestamp is here. This one looks like it's going month, day, year, year, space, hour, colon, minute. And it looks as though the suspended sediment concentration is coming in just fine. The description in the units or milligrams per liter here. So if I click next and we finish off that process, it's going to bring that data in for us. And if we just right click very quickly to quick view that data, we're going to get a view of it in quick view. And you can see here the lines are all joined together. But if I go up to the chart properties right here, and if I go into the curves tab, I can choose to make this a scatter plot. That is, we won't connect the lines. And if I apply that and go OK, you can see actually the individual samples we now have. And this is a fairly regularly sampled site, so there's a fairly high density of sensor or of grab sample data for this particular site. So what we're going to want to do now is actually perform a calculation to multiply the concentrations we have by the flows. So to do that, we'd go into the Math and Statistics roll-up toolbar and we'd grab a Math Toolbox. Now the Math Toolbox can operate on up to 2 time series at a time, and the first part of the calculation will be taking our flow data and multiplying it into our actual concentration data going through. So if I double click on the Math box, what we want to do to begin with is take a 2-port operation, so we're working on 2 time series here, and we're going to work on the raw time series from both of these input ports, and the operator between them is going to be point-by-point multiplication. Now in the options, we're going to want to make sure that the output time series is on the same timestamp as the time series coming from port number 1. So I'm going to specify we're going to trim or pad our time series out to the length of port number 1, so that would be the flow time series. And I'm going to select an output sampling interval of hourly data. And I'm going to rename this, the output time series is going to be the SED flux. Now my time series of flow is in cubic feet per second, and my input sediment load data is in milligrams per liter. So the units out of this is actually going to be a fairly strange unit, and we're going to do a conversion of that unit in the next step. This is going to be milligram cubic feet per liter second. It's a bit of a strange unit, but we're going to convert that in the next step. When we click apply and we run that process, we can see on the output of this time series box we've got a time series, and this actually represents our sediment flux, and it's in some pretty weird numbers out here. So what we actually want to do is do a unit conversion and apply a constant value to this. So if I go and grab another Math Toolbox, and if you notice here I can connect this port up to the input port of the next Math box, and this is going to be a 1-port operation. What we're going to do is multiply, or just, we're not going to add a constant value, we want to multiply by a constant, and the constant I want to multiply by is going to convert us to a reasonable unit. And in this case, I want to convert to tons per hour, and in that case my constant of exchange is going to be 0.0040775, and that will convert me from that milligram cubic feet per liter second into tons per hour. And if I apply that and run that, on the output, we'll see that result. Now, one of the things I actually wanted to do there that I didn't do, if I go back in, is actually to change the output. I didn't change my units here, and I wanted to change those into tons per hour, and I'll change my output description as well to be sediment flux, in this case, in tons per hour. I'll name it for Charlie Creek in this case as well. We'll apply that and we'll run that. If I click OK, we'll now see that output is the sediment flux, and if we quick view that, once again, we'll get a view of the data here. Now, that's not particularly useful data, since what we actually want to get a handle on are our loadings. So maybe we want to actually calculate how many tons are going through over the course of a week. Well, fortunately, our time series is an hourly time series, and in addition to being an hourly time series, we can use the descriptive stats toolbox to actually go and calculate some summations. So if we want to calculate how many tons come through per week or per month, we can certainly do that. So I'm going to wire up the output here in flux of tons per hour into my descriptive stats toolbox. If I double click on the descriptive stats toolbox, let's say I want to go in and calculate my weekly tons coming through. And in order to do that, I need to sum up all of those hourly values of the tons per hour, and that'll allow me to actually calculate those values. And if I click compute here, it'll go through, and for each one of these weeks, it'll give me the sum, or the total number of tons flowing through per week. I could, of course, export this if I wanted to. I could export it directly from the toolbox as a report, or just export that as a matrix. But I've also decided to calculate this as an output port time series. So you can see here I've got my sed flux of Charlie Creek raw weekly summation values, which actually is my load data. So if I actually go and click on this time series and the output port properties, we can exit this toolbox and see that this is actually my load data on the right-hand side here. If I quick view it, this is my weekly load in tons coming out, my total tons coming through for each one of those weeks during my water year. So that's how, by using these three toolboxes, first the math to multiply these two time series together, then the math to do the unit conversion, and then the descriptive stats to actually run the summation, we can very easily do a combination for a loading calculation. And that concludes how we use these math toolboxes to actually do the loading calculation.